Hello everyone, I'm here to talk to you about the internet and DNS and you. And I'm James Kim, and here I am. This is my LIS590LW2 Lightning presentation. So, let's imagine a scenario where I'm sitting at my desk. There's me. And I decide I want to go to Disney.com. So on my keyboard, I tap that in, tap, and pop that into my browser, and voila, Disney.com appears on my screen. So we kind of take that for granted, but what really happens between my computer and Disney.com, and what takes place to get that onto my screen? And that's where DNS plays a pretty big part. So DNS, right here, DNS, stands for Domain Name Service. Now, what DNS does is it ties websites like Google.com, to an IP address. DNS was invented in 1983 at the University of Irvine, and what it serves to do is helps to give you easy to remember names like Google.com, and ties it to IP addresses, which are sequences of numbers from 0 to 255, and there's 4 sets of them. So a typical IP address might be 120.140.12.98. So how does DNS come into our internet browsing? So let's say you're at your computer and you go to illinois.edu, google.com, or CNN. So all of these websites have IP addresses for them. What DNS does is that it translates these addresses into these IP addresses and then returns them to your computer so that you can now navigate to the physical location, or rather the network location of where these websites lie. So to put that into a more simpler example, let's say that you are at your house, or I'm at my house, and I want to send a letter to Mr. Carrot. So there's Mr. Carrot's house. Now, if I want to send a letter to Mr. Carrot, that's right here, that information is useful to me, because I know where I know who is supposed to get this letter. But to Mr. Postman here, that information is not very useful. He's going to be confused because he doesn't know where Mr. Carrot lives. So this information for him is no good. What he's really interested in is a more conventional physical address like this here, where it says 123 Field Terrace, somewhere, Illinois 60077. Now, once he has this physical address, he can then send this email, or he can send this letter over to Mr. Carrot's house, and he doesn't actually care who this person is. He only cares about this part. But provided that he has this address, he's happy, and the mail makes it over to Mr. Carrot's house. But let's imagine a scenario where you don't know where Mr. Carrot lives. So what do? Well, you might decide to ask one of your friends. So you ask, where does Mr. Carrot live? And you're hoping to get the address back. So if your friend knows, they'll tell you where the address is. Once you have the address, you can now send your mail on its merry way and hopefully get a reply in return. But what happens when your friend doesn't know? Well, in a real life situation, you'd probably ask your other friends, like Mr. Pointy Hair, Mr. Cat, or Mr. Elf. But in the DNS world, you have no other friends. So what do? Your friend here, let's call her DNS, it's a very pretty name, doesn't know. So in the DNS world, what ends up happening is your friend, who you talk to, your only friend, asks another friend. And if your friend doesn't know, they ask another friend, and so on. Eventually, it gets to somebody who does know. And then they get that address, and they return it all the way back. And very similarly, that's how DNS works too. So let's say that you are trying to go to dogs.com. So like before, you're going to ask your friend DNS. Now, in this case, you're going to be asking your local DNS server, which most likely is the DNS server of your ISP, or your internet service provider. Now, every ISP does have one, so if you are at home using Comcast, then you're going to be communicating with the Comcast DNS server to get the information that you need. And if you're on campus, you'll be asking the campus DNS server for this information. Now, your ISP, or your ISP DNS rather, doesn't know where dogs.com actually is. However, they think they know, well, they know who knows more information. They know that dogs.com lies in the .com domain. And they happen to know that information, so they'll send this request on to the .com DNS. Now, the .com DNS server doesn't know the IP address to dogs.com. However, they do know the DNS server that actually services dogs.com's physical machine directly. So they'll forward this on to the dogs.com DNS server. Now, the dogs.com DNS server is directly tied to the physical machine here that services dogs.com. And they know that IP address because they provide the DNS services. So they'll grab this IP address right here, and they'll send that back. Now, you have this IP address. What do you do next? It's just a bunch of numbers. Well, this is how it's going to work. You have an IP address that's come back from the DNS server. So something like this. But what you really want to get is, let's say, google.com. Now, for those of you who have been observant, you'll notice that in the front of your browser window, it'll say HTTP. Now, this stands for Hypertext Transfer Protocol. So when you type in google.com after HTTP, it's making an HTTP request to google.com, or rather, the server that contains google.com. So it's essentially the same thing as putting in the whole IP address right behind it. But what's this? That 80 gets injected when you make an HTTP request. HTTP requests assume that you're traveling to port 80 of that IP address. Now, what's port 80? So imagine that this IP address is a building. That's this address. And port 80 is going to be a specific door. Now, this door only knows to give out certain deliveries. In this case, they only know to give out websites. Now, while not all servers are going to have an HTTP port open, and some IP addresses that do serve websites might actually have their HTTP port at a different address. That causes some interesting situations, especially if your browser doesn't know where to navigate, but that's a talk for another day. So you have the mail that you want to get out, and you have the postman who wants to get that mail over to you, and then you have your helpful friend that gives you the address, and of course, last but not least, we have Mr. Carrot, who's eagerly expecting you your mail so that he can send you a batch of cookies in return. So we know that there's a couple components. There's the DNS server, DNS, and there's you, the user request. There you go. There's the browser, and then there's the actual website. So to kind of tie these together, guess what you are? Well, you are the request. The postman is actually the browser. Your friend over here is the DNS server. And of course, Mr. Carrot's house is representing the website itself. So these all work together to get you this website delivered over to your computer. So you have this IP address, but that's only after certain things happen. You first make a request to the browser to go to something like dogs.com. The browser then relays that to the DNS server, and then a whole bunch of things happen, and then the DNS server grabs the IP address of dogs.com, returns that to the browser, allowing the browser to then navigate to dogs.com. And then you're able to get that page loaded on your browser. Ta-da! So in a nutshell, that's DNS, and that's how the internet works. And hopefully that was informative.